welcome back again. In this session of week 4, session 1, we will be introducing about the data needs, importance of data for any research. Earlier, we have already covered in week 1 all about the research types, stages of research. Then we also discussed about the sampling methods, and we had discussed that once you are identifying the sample, then only you will be collecting data. Now, it is important to understand why data is really very important, very critical for any research. In this session, we will be discussing, covering the data concepts, and we will be trying to understand how to convert data to information and the basics of descriptive statistical analysis. In this session, we will be trying to cover the concept of averages, concept of dispersion with a lot of illustration. I hope it will be very clear for all of you. What I was trying to suggest, the data is really very critical for any research, and we can say data is the building blocks for any research. Now, before starting any research, we need to ask ourselves, do I really need data? Why should I need data? If I need to have data, then what type of data? We should discuss the classification of data and the sources of data from where we will be collecting the data. We will of course discussing briefly different data collection method which will be appropriate, and more interesting, in the next session we will be discussing in detail how to have different scales or the measurement scales or the instrument for observing, noting the data. And types of research methods will be automatically covered in this session also. Now, let us discuss very briefly why data and what exactly the data need for any research. Once we are clear about the exact need of the data, then selecting data, collecting data will be easier. So, for that, let us classify, understand different types of data. From one angle, we can classify data into two ways. One is primary data, another is secondary data. Primary data, as you understand, which is collected by us for the first time, that is called primary data. It could be example like you are collecting feedback from the interviewees, and secondary data which is already published. As example, you can say the census data is the best example of secondary data. Now, from another angle, we can classify data into two ways. One, qualitative data, and another is quantitative data. Suppose the amount of rainfall, that is quantitative data. Now, suppose how much care parents give to the siblings or the children, it could be qualitative data. And you can also classify into categorical data also. Now, sometimes data is either collected by us or it is automatically reported to us systematically. So, that could be the further classification. It could be auto-generated or it is collected. Now, another interesting classification of data is we observe data, we collect data, how it changes, that I will be calling observational data, and we do experiment, that will be called experimental data. Last but not the least, try to understand, sometimes we would be needing some random data, and sometimes random data may not be of use. For a specific research, we may be needing some purposive data. We will be giving example how we need, where we need purposive data, how and where we need random data. Now, let us discuss how do we identify or decide the data sources. Should we go for the entire population or should we go for the sample method? As we have already explained, in sampling section that a small group is called a sample. For example, from all students of a college, we can select a select few of the students as a sample. Now, it could be finite, infinite, and it could also be countable and uncountable. Uncountable example could be stars in the sky, and countable could be the presently admitted batch of students of any college. And we may be using data sources, secondary databases, like most common example could be census data, and we also have databases by different parties like Center for Monitoring Indian Economy, that is called CMI, or we can also have PROES databases. And sometimes you may be handling some very, very rare, scarce cases, rare samples. Say for example, a lesser known disease called Ebola. The Ebola virus affected patients you may not get plentifully. So, how to get them? So, that could be a very challenging thing for the researcher. Now, another interesting thing while collecting data or the type of data, one should be very careful about the outliers. Outliers is one which is something not in the normal range, either very, very low or very, very high, something called abnormal extremities. Those are called outliers. In a locality, a village which could be a rich family, super rich family could be one of the example of outliers. Now, let us try to understand once you have got data, what do you do with the data? How do we process the data? And what is the basis of analysis? Why we go for data analysis, and what is the techniques of data processing? Now, try to understand, in research we wanted some information. This information will be obtained by processing data. Now, data as we understand is nothing but some facts and figures, and we have already discussed that data could be quantitative, qualitative, it is either primary or secondary, and we may be referring some databases, it could be online, offline. Once you have the data, required data, then we have to have some processing other to get the information. Then we analyze the data, and this is for the purpose of creating knowledge. First example, my first example could be the database of students of a college, usually handled by the admin department, where you have got number, roll number, section, background, gender, everything like this, as you can see from the monitor. But this is not handy and this is not information. Next, if you tabulate, say for example, how many are seniors having work experience, say for example, if it is part of 2021 admission, how many passed before 2 years, how many passed before 4 years, how many passed prior to that. So, that table which you can see from the monitor is much more informative than the previous raw data, and that is data. This one we can call it as information. Further, if you can put it graphically, maybe a pie chart or a bar diagram, that is more handy, more informative, and this is more useful. My second example could be COVID data. As you can see, the first table, that raw data or published data we cannot make out. What is the gravity of situation and where the administration should first handle on priority. If you check the statistical table, we cannot make out anything. If you take the pictorial graph that I am showing, it is about the Odisha, is the first page of the COVID situation. Those who are aware about the statistics or the history of data, that one district called Ganjam district on coastal Odisha, it was very, very acute. All were very much fearful, because lot of migrants were working at Surat and Gujarat. When they came, all feared the COVID cases were rampant in that particular district, and it was declared hot zone, red zone, and the district administration tried to manage, as the part of their micromanagement. Now, as you might have guessed from two examples, I can say briefly, even a single figure can also be called as an example of information. Say for example, if we are telling the fatality, the death percentage, 2% of the positive cases are dying. So, the 2% one figure is also information, and that tells the tale. And in that context, we have also shown a table or a graph can also be information. Now, going further, as we are going to introduce some of the minimum basic analysis tools, first and foremost is averages. Most commonly, we use average as piece of very interesting information. Let's see this example, example 1. Suppose this data about the 30 buyers, those who are buying video recorders from Sony Music World of a city. Now, if this is the age, from this can we make out anything? Who are the most buyers? Which age group they use the video recorders? How do you know this? Should we go for just the mean, just the median, or just the mode? So, the term comes to our mind that this raw data should first be tabulated, then we can go for the averages. This I am leaving for exercise. I will be telling some hints how to solve. Let me present one more example. Suppose we have 10 sales executives looking after the sales of Maruti Nexa, and they are working in one showroom, say for example of your city, and the superior ASM sales manager is trying to find out who is efficient, who is not. Suppose he has got data for the 4 weeks of a month, and these are the sales figure. One executive is in a position to sell how many cars. Say for example, first executive, first week 11 cars, second executive 7 cars, like this is called the raw data. Can I ask you, this data is primary or secondary? If you can guess, this is primary for that particular showroom. If it is published and if you are using subsequently, this could be secondary data. Now, how to know who is efficient, who is not? Can you think about it? This again I am putting it as part of exercise. These are the hints you can discuss. I can briefly suggest that if you can find the averages of rows and columns, what happens? Think over, this is one assignment, and further assignment you first may go for the tally sheets, then you can find the frequency table. Now, let us briefly summarize some of the concept of the descriptive statistics. If you are collecting raw data, first and foremost we have to have a frequency table. That is called tabulation. Once you have got frequency table, then you convert it to different suitable graphs. You can also go for the percentages. Once you are done with the graphical analysis, the next stage could be go for the averages. In statistics books, which you might have covered, it is part of the central tendency. We will also be needing to understand the dispersion. I will give some examples where to apply averages, where to go for again dispersion and correlation. Now, let us try to give some examples of averages, but before that we will be trying to define very briefly, quickly what we understand have different averages. First foremost will be arithmetic mean, or simply we will be telling mean. Next is geometric mean, next is harmonic mean, and the formula I may not tell you, you might have covered. Other averages could be median and mode, and they have got their applications. And let us check our basic knowledge on averages. Please check this graph, and this frequency curve is based on the frequency table, and we have got two distributions. If I ask you compare distribution A versus distribution B, if I ask you which distribution A or B has or possibly will have larger value, A or B. If you can check, B value has got a peaker towards right hand side, so the answer should be B. Now the next question would be, which is more likely to produce a small value than the large value? I think you can answer A. If this is about the raw concept attendees' ages, if I ask the question, which is a better representation of the distribution of ages of a raw concept? A raw concept, if you agree with me, that mostly attended by the youth, so the lower side would better distribute and A would be the answer of C bit. Now the last question on this exhibit is, which is a better representation if you are talking of the patient's waiting time, those who are waiting for a doctor's office. Try to understand, try to answer yourself, I am not answering. Now one more example is, on this example which I am showing you, one in black color, one is red color, and the two distributions are A versus B. And if these are the marks or the scores secured by the students, same set of students on two subjects. If we ask which subject, which question possibly was more difficult, A or B? Any answer? As A is the lower side, the set A should have been more difficult. B, students have got more marks. Now moving ahead, next would be trying to understand the concept of dispersion. Dispersion is nothing but the variations, fluctuations among the observed data where you are observing, and such dispersion or scatterness, which is the variation from the central value or average value, is usually measured by some of the known methods, and the known methods are range. Range is nothing but the highest value and the lowest value, and we also have mean deviation and quartile deviation, but mostly in research we will be confining ourselves to variance and the standard deviation. The minimum relation between standard deviation and variance is, standard deviation is the square root of variance. Now we just discussed that once we have frequency table, we can plot it as frequency curve. Try to understand the classification of frequency curves. One could be symmetric or normal, another is not symmetric, which we will be calling asymmetric or skewed curve. If a distribution or if a curve is asymmetric or skewed, we have two types of skewed curve. One is negatively skewed, which is more stretched, elongated towards the left side, that is called negatively skewed curve. If one is more stretched, elongated towards the right side, that is called negatively skewed and versus positively skewed. Now let me give you some interesting examples. The example of the biometric attendance of employees. From this we will be checking, understanding, clarifying our knowledge on averages and variance and scatterness. It is a very interesting example to me. Suppose we are observing the entry attendance timing of either employees or the students, how they enter. Say for example, this HR data, how we will be analyzing. Some hypothetical cases, I am observing my students, how they have entered my class. I am observing for the entire 30 days or 31 days of a month. Say for example, I expect students to enter my class which starts at 9:30, and I can perhaps see students, some exceptions, genuine exceptions up to 9:40, and students coming as early as 9:20. Say for example, Mr. Mishra. If this kind of variation is there, what do we understand? Is it acceptable? If you check the average entry time, it might be close to 9:30. But as a decision maker, as a researcher, please be careful, is it acceptable or not acceptable? Try to understand this fluctuation is unacceptable, because class starts at 9:30, one is expected to come by 9:30 or before 9:30. So this variation is not welcome. Next, let us see of another person, say Miss Biswas. Please see, she almost comes before time, and maybe like last one or two occasion she was slightly late. We can understand the genuine thing, and this is welcome, and you can decide. So what I am suggesting here, not only average, we are seeing the degree of variation, degree of scatteredness. Now say for example another Miss Sinha. See, earlier she was coming daughter time, slowly her entry time is really deteriorating. This is a cause of concern. If it is something like employees entering one office, the HR department must take note of this deviation. Next one, please see a person, Mr. Mukherjee, who has been in Lightoben regularly irregular. He was coming almost late. And please see, one day he was the first to enter the office. What happened? Maybe he got to know that very day there will be inspection, and he wanted to show off that he is the most sincere employee of the organization. And please see, if these are the observed data, this particular day data we can very well ascribe as one outlier. So you should not be surprised that this should be dropped from your analysis, because that will inflate unnecessarily and that might not give you correct data. Next, moving further, I will be giving example of comparing two cricketer of Indian cricket team. If you find secondary data, what they have done, to make it simple, suppose we have collected some random data of 5 appearances, these are the data. Deliberately I have taken such data, if you can check yourself later, the average for Ajinkya as well as for Ambati is coming to 50. Suppose you are one of the selector, whom you select and why? When the average is same, can we say both are equal? I think you will agree, no. What I am indirectly asking, that we should also go for the dispersion or the variation. So the dispersion is one which you have already suggested, it is not welcome. If the dispersion scatteredness is less, it is more dependable. Less the dispersion, better. I will be giving one more example before we conclude today, and let us compare the shooting events. Who is a better shooter? If you can check the exhibit, there are exactly 6 shots. Shooter 1 in blue color, shooter 2 in yellow color, and the scatteredness is higher for the first example than the second example. So what you can clearly conclude that the second shooter is much better than the first shooter. Why? Because less dispersion, less scatteredness, and more dependable. So please remember, variation is the opposite of precision, and we will be preferring if there is less variation. Thank you very much for listening to this episode.